The rational zero root theorem. The rational zero theorem, otherwise known as the rational root theorem, as its name suggests, is used to find rational solutions when dealing with a polynomial equation, or zeros or roots of a polynomial expression. A polynomial does not always have zeros. This means that the corresponding polynomial equations do not always have zeros. But when they have, these zeros must be rational numbers. Given that the general form of a polynomial, we have the following shown on screen. We have the following shown on screen. From the previous tutorials, it is known that all values of the variable x for which p, x, equals 0 are the zeros, roots, of the polynomial. For example, the values -3, -1, and 1 are the zeros of the polynomial. We have the following shown on screen. Because we have the following shown on screen. And we have the following shown on screen. The rational root theorem states that all rational roots of a polynomial equation with integer coefficients have the form p over q, where p is a factor of the polynomial constant a, 0, and q is a factor of the leading coefficient a, n. The two numbers p and q must be relatively prime. Proof first, let's prove that p is a factor of the constant a, 0. Indeed, substituting the variable x with the assumed root p over q yields, we have the following shown on screen. Multiplying both sides by q, n yields, we have the following shown on screen. Or we have the following shown on screen. Since p divides each term on the left side, it is a factor of the left side of the above expression. This must be true for the right side as well since both sides are equivalent. This means p is also a factor of the term, -a, 0q, n. Hence, since p and q are relatively prime and cannot divide each other, the only possibility is that p is a factor of the constant a, 0. Now, let's prove that q is a factor of the leading coefficient n. For this, we subtract a, np, n from both sides of the polynomial. We have the following shown on screen. We have the following shown on screen. Since q is a factor of all terms on the left side, it is also a factor of the entire expression written on the left. Therefore, it must be a factor of the right side as well, since both sides are equivalent. Given that p and q are relatively prime, they cannot have common factors, then q is a factor of the leading coefficient a, n. For example, in the polynomial, we have the following shown on screen. Considered earlier in this tutorial, we have n equals -1 and a, 0 is equal to 3, n equals 3, as it represents the degree of the polynomial. Hence, all roots must be multiples of -1 or 3. Indeed, we proved by substitution that -3, -1, and 1 are roots for the given polynomial. That is all for lesson 11.3.2. To continue this tutorial, please watch 11.3.3, how to list all possible zeros, roots, of a polynomial equation. Thank you for watching. Make sure to like and subscribe to keep up to date with new videos. For more information, calculators, and tutorials, please visit www.icalculator.info.